A cylindrical pressure vessel has an inner diameter of 4 feet and a thickness of a ½ inch. Determine the maximum internal pressure it can sustain, so neither its circumferential hoop nor its longitudinal stress component exceeds 20 ksi. Under the same conditions, what is the maximum internal pressure that a similar sized spherical vessel can maintain? Aside from getting completely tripped up over my words there, let's take a look at how we'd go about solving this problem. So it's a pressure vessel. And let's look at our cylindrical to begin with. And actually, before we even do that, we're going to make sure that this is a thin-walled pressure vessel. So we're going to look at my pen does not want to cooperate today. So R over 2T, radius over the thickness. So our radius is 4 feet. Our thickness is a ½ inch. This needs to be a unitless number. Those units do not work out. So 4 feet, 4 times 12 is 48 inches. And we're going to divide that by a ½ inch. So our inches will cancel out, and that is 96. 96 is much greater than 10. Therefore, this is a thin-walled pressure vessel. We can use our thin-walled pressure vessel equations. So let's deal with the hoop stress first. Our definition of hoop stress is going to be PR over T. The problem tells us that it can't exceed 20,000 KSI. So that's 20 kips per inch squared is going to be equal to the pressure times the radius of 24 inch. Oh, let's go back there. It's 24 inch radius. I have an inner diameter of 4 feet. That's not right. This is 24. 24 divided by half is 48. Fortunately, we're still well above that. So let's go back and not screw up any more numbers. And a ½ inch thickness. So thicknesses will cancel out. We're going to be left with units of kips per inch, which is fine. If I go and rearrange this, so 20 multiplied by a ½ divided by 24, what we're going to get is we're going to have a pressure of 417 psi. And that's our hoop stress. So that's not bad. That's pretty low, actually. So now let's find our longitudinal stress. That's our stress 2. That's PR over 2T. Pretty much the same equation, slightly different. So we'll do the same thing, fill in the information, where our pressure is still going to be the variable we're looking for. But now we're going to divide that by 2 times a ½ inch. Okay. And so if we go and we solve this for P, we're going to find that P is 833 psi. So looking at this, we're like, wait a second, I thought the hoop stresses would be higher. This is true. Remember, we're calculating out what pressure is going to cause the failure. It's going to fail a lot quicker in the hoop direction at 417 psi will cause us to exceed the 2,000 kips per inch. Sorry, the 20 kips per inch, where it will take an internal pressure of 833 psi to exceed it in the axial direction, or the longitudinal direction. Okay, so there we go. So that we have the maximum pressures that we need for part 1. Part 2, spherical. Well, what do? Well, we've already done it, because spherical, we have longitudinal everywhere, so this would be for the spherical, would be that 833. So it's pretty simple to solve right there.